Yeah, good morning, students. Here, today we are going to discuss motion of a body in a vertical circle, right? So this is also a two-dimensional motion only, but it is a special kind of a circular motion. So in this case, the body is made to move in a vertical circular plane. That's the condition, right? So this circular motion, in this circular motion, this is not uniform circular motion. In this case, every time the velocity of the body, its magnitude also changing with the time. But in uniform circular motion, what we have seen was its magnitude of the velocity was always a constant, but direction was changing. In this case, magnitude as well as direction both will be changing. But for all circular motion, you must know that body needs a centripetal force. That is always necessary, whether it is in uniform circular motion or it is a non-uniform circular. This is a non-uniform circular motion. Vertical circular motion is a non-uniform circular motion. So in this case also, the centripetal force is always necessary. Otherwise, body is not able to make the loop in the circular path. This is the condition. So let us see various conditions of the vertical motion of the body. The figure and everything is written here. This part, this much part is the first part, right? And this can be taken as the second part. This can be taken as the third part. This can be taken as the fourth part. And this is the points to remember, right? Points to remember. So these are the things, right? So the diagram is also showing the body is in a vertical path, vertical circular path. This is the top of the topmost point of the vertical motion. This is the lowermost point of the vertical motion, right? The velocity at the top means at the highest point is Vh and velocity at the lowest point is Vl. It is noted here, right? Many things are shown here. This only figure can be used for many purposes. That is, everything has been described in the board. I think you are able to see it, right? Zoom it and see it, right? Okay, these are the things. So this is a general point. This is a diametrical point. That means at the horizontal point. C is a horizontal point and P is a general point. L is the lowest point and H is the highest point. These are the points we have to calculate. The quantities we have to calculate. TH, that means tension of the string. Let me see this. Just suppose that you are having a string. One of the string is tied to a stone and other end of the string is held by your fingers and it is rotated. Right? When it is rotated, you will feel that the tension is actually acting at your fingertips. Am I correct? So if it is of very big speed, if you are rotating, the tension acting at the fingers also will be more. You can technically reduce the speed such that at a particular value of the velocity, the tension becomes equal to 0 on the top. On the top, the tension becomes equal to 0. When the body comes on the top, you will feel no tension at all, right? So all these things you will we have to calculate. TL is the tension at the highest point. TH is the tension at the highest point. TL is the tension at the lowest point. VL is the velocity at the lowest point. VH is the velocity at the highest point. VC is the velocity at the horizontal point. And VP is the velocity at any point P. VP means V. I will take the VP in terms of VP. I will take V only. No problem. Right. So remember that. These are the things. Now let us suppose that the body is at the lowest point. At the lowest point, you see, when the body is at the lowest point, so this is the ground level, right? At this point, you can see that mg is acting vertically. What is mg? Mg is the weight of the body is acting vertically downwards. And the tension acting on the string is acting in the upward direction, right? So resultant of these two is equal to TL minus mg. TL minus mg will provide for the centripetal force. So that is why it is written here. At L, TL minus mg is equal to VL square divided by R. What is VL? VL is the velocity at the lowest point. So from this relation, we can write TL is equal to mg plus m into VL square divided by R. This is VL square divided by R. this is the highest point is described. Lowest point is described. And now we are coming to the highest point. At the edge, you will see that. You will see tension is always towards the point where you are holding the spring. Tension is always toward the point to where you are holding the spring. And mg is always acting vertical downward because this is a vertical motion. So when the body reaches the highest point, the weight is acting vertically downwards. Therefore, we can write TH and mg both are acting in the same direction, downwards. Therefore, we can write at h TH plus mg is equal to mvh square divided by vh square divided by r. Am I correct? That means the total force acting here is equal to TH plus mg. That will provide for the centripetal force. mvh square divided by r. Therefore, TH is equal to what? mvh square divided by r minus mg. TH also can be calculated. TL also can be calculated. So at H, if TH is equal to 0, when the body reaches the highest point, you are adjusting the velocity such that at the highest point, you don't feel any tension at all. Right? We can reduce the velocity to a particular value only, not below that. So there is up to limited value, the velocity can be reduced to. At that stage, you can just feel that at your fingertips, you don't feel any tension when the body reaches the highest point. So at the highest point, when TH is equal to 0, then we can write 0 is equal to mvh square minus mg, or mvh square divided by r is equal to mg we can write, or vh is equal to rg we can write. So this is the minimum velocity a body can have attained on the top of on the highest point of the vertical point. This can be taken as the critical velocity. So critical velocity of a body moving in a circular path, in a vertical circular path, is the velocity at the top. And this velocity is the minimum, and with which the body can easily loop around the circular path. If we reduce the velocity, again less than that value, less than vh is equal to rg, less than rg, then the body is not able to move in the circular path. That is why this velocity is called critical velocity. So vh can be taken as vh is equal to rg is taken as a critical velocity. So this is the minimum most velocity. Velocity at the and now we will talk about velocity at the lowest point. So velocity is the highest point, minimum value of velocity is the highest one. Remember, when the velocity at the highest point, vh is equal to root of rg, then the tension th must be equal to 0. We can experience it when we do this experiment at our homes using a spring and a small weight, and we are rotating it. When the speed is very high, you will surely feel a very high tension. But we can reduce the speed such that you will be very easier and you'll be happy to move the body in the circular path. At the highest point, you just feel that the tension acting at your fingers is equal. At that time, velocity of the body particle, which is carried together under the spring, will be calculated as vh is equal to root of rg. Vh is equal to root of rg is also called as what? Critical velocity. Now, when the body is at the velocity at the lowest point, that means when the body is at L, what we can write? Body is at L, right? When the body reaches the point L, so the energy at this point, the total energy at the highest point will be equal to kinetic energy at this point. When the body was at this point, it had both kinetic energy and potential energy. What is the kinetic energy? Half mvh square. What is the potential energy? The body, suppose it is taken from this point to this point. What is the total distance? This much is radius, this also radius. R plus R is equal to 2R. Right? H is equal to 2R. And weight is equal to what? mg. Therefore, mg into 2R is the potential energy, and half m into vh square is the kinetic energy. Right? So kinetic energy and potential energy at the highest point will be equal to the kinetic energy at the lowest point. Because why kinetic energy? at the lowest point? Because when the body reaches the lowest point, it is very near to the floor, the ground. Therefore, at this point, there is no potential energy. But when the body is at the highest point, it must have both kinetic energy and potential energy. So it is written here, kinetic energy at L is equal to kinetic energy at H plus potential energy at H. Energy can neither be created nor be destroyed. The total energy at H is equal to the total energy at L. So remember, the total energy at L is equal to only kinetic energy because L is very near to the ground. No height is mentioned here. So kinetic energy at L is equal to kinetic energy at H plus potential energy at H. I think you understand it. So kinetic energy at L is equal to half m into VL square. That is equal to half m VH square. Kinetic energy at the highest point plus mg into total height from this point to this point. So what is the height? What is the height of H from the lowest point? That is equal to R plus R is equal to 2R. mgh. Am I correct? But VH, everybody knows that for minimum value of tension, zero tension, VH is equal to RG. Am I correct? This is the critical velocity. VH square is VH is equal to